Hello viewers, today we are going to see about energy in simple harmonic motion. In the last video I have explained about the kinetic energy and the potential energy. Now today what I want to tell you is, in a single period of time 2 cycles are completed. So what is the proof for it? So we have kinetic energy is equal to half k a square sine square omega t plus phi. That k is the spring constant, a is the amplitude. Potential energy is half k a square cos square omega t plus phi. So these two equations we have seen already. Here if you look into the equations, you have sine square, some value omega t plus phi. Here cos square omega t plus phi. So we will derive a relation connecting cos 2 theta and sin square theta. So the well-known formula is cos 2 theta is cos square theta minus sin square theta. Cos square theta as it is minus sin square theta can be written as 1 minus cos square theta. You bring this minus sign inside, minus into minus will become plus. So cos square theta and once again cos square theta, you will be having 2 cos square theta minus 1. Bring this 2 cos square, leave it and bring this minus 1 this side. So you will be having 2 cos square theta is equal to 1 plus cos 2 theta. Therefore cos square theta can be written as 1 plus cos 2 theta by 2. So this is the formula, standard formula. Similarly, using the same relation, you can derive for sin square theta. Cos 2 theta is 1 minus sin square theta, because cos square theta is 1 minus sin square theta minus sin square theta, you write as it is. Now we have 2 sin square theta, therefore 1 minus 2 sin square theta. So bring this minus 2 sin square theta this side and move this cos 2 theta to the other side. So 2 sin square theta is equal to 1 minus cos 2 theta. Therefore sin square theta is 1 minus cos 2 theta by 2. So what I want to stress is, now sin square omega t plus phi can be written as 1 minus cos 2. Here if it is theta, here theta, here we have omega t plus phi, therefore we have to write omega t plus phi by 2. Now this can be split into 1 by 2 minus cos 2 omega t plus phi by 2. That is, this sin square omega t plus phi can be written like this. So now what will happen? The kinetic energy will become kinetic energy is equal to half k a square. This sin square value is replaced by this one, that is half minus cos 2 omega t plus phi divided by 2. Now if you multiply this value with this, first you will get a constant term and then you are multiplying with the next one. So 1 by 2 into 1 by 2 will become 1 by 4 k a square cos 2 omega t plus phi. Now you note down here 2, omega is 2 pi f. That means you are multiplying the frequency by 2. So in one period of time it completes 2 cycles. That's the meaning, because of this 2. Similarly, if you come across potential energy of k square cos square omega t plus phi can be written as 1 plus cos 2. In the place of theta we have omega t plus phi. There again This omega is multiplied by 2. Omega is 2 pi f. Okay. So you will be having twice the frequency. So in single period of time, 2 cycles are completed. This is the proof. Next we will draw the waveform. Right. This is 0. This is E. So this is one complete cycle from here to here. Then we have a half cycle. This side we have quarter cycle, here quarter cycle. So totally 2 cycles, one full cycle. This is half cycle, this is quarter, and this is quarter. This is one time period, T. So in one time period, 2 cycles are completed. So this waveform is kinetic energy. It goes like this. So this is kinetic energy. Next we will draw the potential energy. So potential energy starts from here. So this is a dotted line. So this waveform is potential energy. So now the total energy E is potential energy plus kinetic energy. So if you add these two waveforms, when kinetic energy is 0, potential energy is E. Similarly, at each and every point you try to add, the result will be potential energy plus kinetic energy will be a straight line, which is nothing but E. So this is a straight line. So this graph is, this straight line is potential energy plus kinetic energy. Okay. Next we will try to draw for the displacement. So this is T. This is T by 2. Here it is T by 4. Here it is 3T by 4. And this is T. Here it is 0. So this is individually we have kinetic energy waveform, potential energy wave, and when you add kinetic energy and potential energy, it will be a straight line. So this is potential energy plus kinetic energy, which is equal to total energy. Here in the x-axis we have time, y-axis energy. The next graph will be x-axis displacement and y-axis energy. So that graph you will see now. So this waveform is kinetic energy. This is 0. This is plus A, minus A, and this is X displacement. Next we will draw the potential energy graph. That will go like this. So the dotted line is potential energy graph. So this is potential energy. Now when you add potential energy plus kinetic energy, that will give you total energy. So the total energy lies here. So this is total energy, which is equal to E. That means that if you see at 0, potential energy is 0, whereas kinetic energy is maximum. When you see at x is equal to A, this kinetic energy is 0, potential energy is maximum. Whereas when it is 0, kinetic energy is maximum, and minus A, kinetic energy is 0. So if you take potential energy at minus A, it is maximum, and at 0, when the displacement is 0, potential energy is 0, and when the displacement is plus A, it is having maximum energy. But at any point of time, if you try to add potential energy and kinetic energy, it will have a constant value. Okay, that's the meaning, because this is minus A, at just minus A, this is minimum, whereas this is maximum. So if you try to add potential energy and kinetic energy, you will have a uniform constant energy. So that's all about this topic. In this topic we have seen why the frequency is doubled, or I can say in the same period of time the kinetic energy graph and the potential energy graph completes 2 cycles, and we have drawn 2 waveforms, one x-axis time and y-axis energy. The second graph is x-axis is displacement and y-axis is energy. In both the cases, addition of potential energy and kinetic energy gives a constant value at any point of time here, or any point of displacement in this case. Thanks for watching this video. Nandri.